Okay, in this video, we're going to be talking about Section 4D, dealing with loan payments, credit cards, and mortgages. Okay. We're going to first talk about some of the basics of a loan. The principal in this case will be the amount of money owed at any particular time. That's going to be the amount that you borrow on that loan. The installment loan, or what we call an amortized loan, is a loan payment that is going to be paid off with equal regular payments. And then finally, the loan term is the time that you have to pay back that loan in full. Okay, usually it's going to be in months. Okay, now the first thing we'll look at is installment loans. Here, this is where we pay off a loan using equal regular payments. And to calculate the exact amount, we use the loan payment formula. And this is for installment loans. And that's this formula. PMT is equal to P times the quantity A, PR, divided by N, all divided by 1 minus the quantity 1 plus APR divided by N, raised to the N times Y powered. Now, what do these variables mean? Well, in this case here, your PMT is going to be your regular payment amount. The P is the starting loan principal, that is the amount that you borrow. Your APR is going to be the annual percentage rate, and this should say in decimal form because it'll give you the percent. You want to change it to a decimal. And then N is the number of payments per year. And Y is the loan terms. That's going to be in years. Now, usually when you pay off a loan, it's going to be paid off using regular monthly installments. Okay? Now, the principal and the interest for installment loans. The portions of installment loan payments going toward principal and towards interest vary as the loan is paid down. Early in the loan term, the portion going towards interest is going to be relatively high, and the portion going towards principal will be relatively low. So as you start off making the payments, the majority of it will go to interest, and what's left of that will be a small amount going to principal. But as we progress, as you continue to make your payments, what's going to happen here is the interest, the amount that goes towards interest will gradually decrease as the amount towards the principal, going towards principal, will gradually increase. Okay? So, let's consider the following loan. This is example 1. And we're going to complete parts A through C below. In this case here, an individual borrowed $90,000 at an APR of 7%, which will be paid off with monthly payments of $636 for 25 years. So here we're going to complete part A is identifying the amount borrowed, the annual interest rate, the number of payments per year, the loan term, and the payment amount. So in this case here, the amount borrowed, says here the initial amount, well, an individual borrowed $90,000. That will be your amount borrowed. $90,000. The annual interest rate is, and here's the APR, 7%. So just fill that in. And then the number of payments per year is how much? Well, in this case, per year. He's making monthly payments, so in 1 year, he's going to be making 12 payments. And then the loan term is given right here, 25 years. So that person has 25 years to pay off a $90,000 loan. And the payment amount is, well, we have the monthly payments of $636. Okay? So all we're doing here is just filling in what was given to us in that problem in Part A. Now, Part B, how many total payments does the loan require? Okay, I'm going to do Part B down here. It's going to be monthly payments, so that means in a year there are going to be 12 monthly payments, and he's going to be doing that for 25 years. So if I multiply 25 times 12, we will get 300. So in this case, there's going to be 300 payments towards the loan. And what will be the total amount paid over the full term of that loan? Well, we got 300 payments in it for the entire loan. Each payment is $636 per month. So $636 per month for 300 months will give you this. $190,800. So that means this person will be paying $190,800 over 300 months for a $90,000 loan at 7%. Okay. So I'll go ahead and fill in that amount. Now Part C. Of the total amount paid, what percentage is paid toward the principal and what percentage is paid for interest? Okay, now to find that out, we're going to take the principal, that's the amount that the individual borrowed, divide that by the total number, the total amount that is paid, multiplied by 100%. So that principal was $90,000. That's the amount borrowed. Divide that by the total amount that was paid, that would be paid, that'd be $190,800 times 100%. So in this case here, 90,000 divided by $190,800 times 100. Now, if we were to round that off to one decimal place, it will be 47.2%. So 47.2% of that loan is going towards principal. Okay? And what about the percentage paid for interest? Okay? Well, if I take that $190,800, which is the total amount paid, subtract that from the loan amount of $90,000, you'll be left with $100,800. $100,800. That is going to interest. That amount is your interest. And as you can see here, we're paying more on interest than the amount that's being borrowed. So here, we'll take the interest, divide that by the total amount that's paid, times 100%. And that interest was $100,800 divided by the total amount paid, which is $190,800 times 100%. And that will give us this. You end up getting to one decimal place 52.8%. So 52.8% of that loan amount is going towards interest. Okay. So again, we're paying more on interest than we are when we're bought for more than what we borrowed on that loan. Sometimes that can be a bad thing to borrow a loan and you're paying more on the interest than what you borrowed. Okay, now let's look at example 2, where we're going to use that formula here. Consider a student loan of $17,500 at a fixed APR of 9% for 15 years. Part A, you want to calculate the monthly payment. Part B, determine the amount paid over the term of the loan, and of the total amount paid, what percentage is paid toward the principal and what percentage is paid for interest. Okay, so in this case here, we're going to calculate the monthly payment. So that's part A. In this case, we have a principal of $17,500. The APR is 9%. That's the annual percentage rate. But we need to convert 9% to a decimal. So if you don't remember, we do 9 divided by 100. Drop the percent sign. That will give you 0.09. Y is the number of years. That's 15 years. And we're calculating the monthly payment. That means your N has to be 12. Okay, so now this is where we use that installment formula. PMT, that's the payment, is equal to P times your APR divided by N, all divided by, this is going to be the quantity of 1 minus the quantity 1 plus APR divided by N. And that's raised to the negative N times Y. Okay. And that is this formula right here. So in this case here, the payment is equal to, P is 17,500. So just go and just substitute. Times your APR is 0.09. Divided by N, that's 12. All that's divided by 1 minus, and in parentheses, 1 plus APR of 0.09 again, divided by 12. Now that's raised to the negative N. N is 12, so I'm going to have a negative 12 times Y, which is 15, as my exponent. Now all of this can be typed in the calculator here, as you will see. So the numerator, I'm going to do left parentheses 17,500 times 0.09 divided by 12, close parentheses. And then divided by The bottom, the denominator, left parentheses, 1 minus, and then left parentheses again, 1 plus 0.09 divided by 12, close the parentheses, and then hit your hat key for your exponent, and then negative 12 times 15. Close parentheses. Oops. You want to use your right arrow key to get out of the exponential part and then close your parentheses. Now for the negative key, that negative key is at the very bottom next to the decimal point. Don't get that negative key confused with the minus sign up here. And then press enter. And let's say I want to round this off to 2 decimal places since we're dealing with money amounts here. This will be $177.50. That will be the monthly payment for this $17,500 student loan at a fixed APR of 9% for 15 years. So you'll be making monthly payments of $177.50. Okay, now part B is the total payment over the term of the loan. So that means you're going to be making you're going to have to pay $177.50 per month. And for 1 year, you have to multiply that by 12. And for 15 years, here you have to multiply by 15. Okay? So that 12 means that 12 months in a year. So you want to find out how much you got to pay in a year. And then the 15 years, you have to multiply it by 15. So if I do 177.50 times 12 times 15, this will be $31,950. So the total payment that's the total payment over the term of that loan is going to be $31,950. And now part C. Of the total payment over the term of the loan, what percent is paid towards the principal and what percentage is paid toward the interest? Okay, so let's find out the percentage going toward principal. Okay, that's going to be equal to the principal. You go. The principal right here is $17,500. So here, that's the principal divided by the total payment, $31,950. The principal divided by the total payment, and then that's going to need to be multiplied by 100%. So here, if I take the principal of $17,500, divide that by the $31,950 times 100%, this will be, to one decimal place, 54.8%. Now here we can find the percent towards the interest. I'm going to give you a quicker way of doing that to get the percent towards the interest. Okay, because keep in mind, your total payment is going to be 100%. And 54.8% of that is going towards the principal. Well, subtract the 54.8 from 100%, you're going to get 45.2%. So 45.2% of that will go towards interest. Okay? Because here the total payment represents 100%. We found out that the percent of that going towards the principal would be 54.8% of that total payment. So the rest has to go to interest. So subtract 54.8 from 100% to get 45.2%. Okay, here's another example of that. Let's consider a home mortgage of $250,000 at a fixed APR of 6% for 20 years. Complete parts A through C below. Here we're going to calculate the monthly payment and determine the total amount paid over the term of the loan, and of the total amount paid, what percentage is for the principal and what percentage is for interest. Okay, in this case, we're considering a home mortgage of $250,000. The APR is 6%, but 6% as a decimal, if you take 6 divide that by 100, you'll get 0.06. The Y is the number of years. That was 20. And we're doing this monthly. Here we're calculating the monthly payment. That means in a year, you're making 12 monthly payments. So N is equal to 12. And now the formula, PMT is equal to P times APR divided by N, all divided by the quantity of 1 minus the quantity of 1 plus APR divided by N. That's raised to the negative N Y, close parentheses. Now let's substitute those values into that payment formula. If P is 250,000 times the APR, which was 0.06, over N, which is 12. Now all that's going to be divided by 1 minus 1 plus the APR, again of 0.06, divided by 12, raised to the negative, N is 12, times Y is 20. Now in this case, we'll go ahead and type all that in the calculator. Here we got left parentheses, 250,000 times 0.06 divided by 12, close parentheses. And then that's going to be divided by, and then left parentheses, 1 minus another left parentheses, 1 plus 0.06 divided by 12, close parentheses. And then press the hat key for your exponent. And then if you want to, you use left parentheses here, and then press the negative key at the bottom, and then 12 times 20. Close that parentheses. Then use your right arrow key to get out of it, and then close it again. And then hit enter. Now we round to 2 decimal places since we're rounding to the nearest cent. It will be $1,791.08. So the monthly payment will be $1,791.08. That will be the answer to part A. Now part B. They want the total amount paid over the term of the loan. Well, we know we're paying $1,791.08 per month for 12 months. And the term, 20 years. So $1,791.08 times 12 times 20. This will be $429,859.20. Okay, that will be the total amount paid over the 20 years of that $250,000 loan. Okay. Now, part C, we want the total amount paid, what percentage is for principal and what percentage is for interest. Let's find the percentage for principal. That, of course, is the principal divided by the total payment, the total amount paid. That principal was that $250,000 mortgage. Divide that by the total amount that's paid, that's $429,859.20 times 100%. And I forgot the times 100% here because we want to change that to a percent. So 250,000 divided by $429,859.20 times 100. If I round that off to the nearest percent or to one decimal place, it'd be 58.2%. So 58.2% of that loan or mortgage will go towards interest. Okay, now let's find the percentage for interest. And you know what? The total payment right here, this right here is your total payment. That represents 100%. But we pay 58.2%. That's going towards the principal. So if you subtract 58.2% from 100%, you're going to get 41.8%. So here, 41.8% is going towards interest. Okay, here's another one of these as well. Let's say a loan of $7,500 for a period of only 2 years. And the fixed APR is 8.5%. Here we're going to calculate the monthly payment, determine the total amount paid over the term of the loan and the amount paid, what percentage is for the principal and what percentage is for interest. Okay, so let's start by calculating the monthly payment. We have a loan of $7,500. That's going to be what P is. The Y, the number of years, that's going to be 2. Your APR is 8.5%. But 8.5% as a decimal will be 0.085. Just take 8.5, divide that by 100, and drop the percent sign. And we're dealing with a monthly payment, so that means that 12 months in a year is equal to 12. So here we're going to use that same formula for installment loans. And notice in my case, I always keep writing that formula. Now, let's substitute into that particular installment loan formula. Okay, your P is 7,500. So we got 7,500 times your APR of 0.085 divided by N, that's going to be 12. And all that's going to be divided by, my denominator is going to be this, 1 minus, and in parentheses, 1 plus APR of 0.085 again, divided by N, that's still going to be 12. That's going to be raised to the negative N times Y. N is 12, Y is 2. So it'll be negative 12 times 2. Now, if we type this in, left parentheses 7,500 times 0.085 divided by 12, close parentheses, and then divided by, and then left parentheses, 1 minus, now left parentheses, 1 minus left parentheses, 1 plus 0.085 divided by 12, close parentheses, and then press the hash key for your exponent, and then left parentheses, negative 12 times 2, close parentheses, and then use your right arrow key to get out of that exponential part, and then close your parentheses, and then hit enter. All right, to the nearest cent or to 2 decimal places, this will be $340.92. That would represent the monthly payment of that $7,500 loan for 2 years at 8.5%. Now, part B. Determine the total amount paid over the term of that loan. So here we're making payments of $340.92. And it's monthly, so that means that there's 12 months in a year. And then for 2 years, we need to multiply by 2. Okay? Because it says a period of 2 years. So 340.92 times 12 times 2. This would give you $8,182.08. So that means the total amount paid, and that does include the principal and interest, will be $8,102.08. Now for part C. Of the total amount paid, what percentage is for principal and what percentage is for interest? Let's find out what the percentage is for principal. That's, of course, the principal itself divided by the total amount paid times 100%. So here your principal was $7,500 divided by the total amount paid, that's $8,182.08 times 100%. Okay. So when we do the math, 7,500 divided by 8182.08 times 100. All right, to the nearest, to 1 decimal place here, this will be 91 91.7%. So 91.7% of that particular, of the total payment is going towards the principal. Now to find the percentage going towards interest, well, that total payment, that's 100% altogether. And we have 91.7% of that going towards the principal. So subtract 91.7% from 100%, you're going to get 8.3%. So 8.3% of that total payment over the 2-year period will go towards interest. Okay. All right, next we'll talk about credit cards, because that's something that most of us would have in our wallets, credit cards. Now, credit cards differ from installment loans in that you are not required to pay off your balance in any set period of time. Now, in this case here, a minimum monthly payment is required when you have a credit card. And monthly payments generally covers all the interest but very little principal. And the sad part about it, it takes a very long time to pay off a credit card loan if only the minimum monthly payments are made. And if you notice on your credit card statements, they do have where if you only make the minimum payment, it's going to take you this amount of time in months to pay off that loan or pay off that credit card. And the interest can be outstanding. And then they also give you a 3-year. If you pay this, if you want to pay it off in 3 years, then this is the amount that you have to pay. Okay? So the more you pay off on that credit card, then, the less monthly payment, the less in interest you have to pay. Okay, so in example 5, suppose that on January 1, you have a balance of $5,700 on a credit card whose APR is 17%, which you want to pay off in 1 year. Assume that you make no additional charges to the card after January 1. So in part A, you want to calculate your monthly payments, and then when the credit card is paid off, how much will you have paid since January 1, and what percentage of your total payment in part B is going towards interest. Okay, so let's look at this. I'm going to write what's given to me on the side here. Okay, we have a balance of $5,700 here. That's your P. The APR is 17%. And to be honest with you, I've seen credit cards with higher interest rates than that, between 20 and 30%, probably even more than that. 17% would be 0.17 as a decimal, 17 divided by 100. And we want to pay this off in 1 year, so your Y is going to be equal to 1. And we're making monthly payments, so your N is going to be 12. Now we can still use that formula here for installment payments. That PMT is equal to P times the quantity APR divided by N, all divided by a quantity of 1 minus, in parentheses, 1 plus APR divided by n. That's raised to the negative n times y power. And then we go ahead and substitute in that formula. Your P is $5,700 times the APR, that's 0.17, divided by 12, all divided by, in the denominator we're going to have 1 minus, and in parentheses 1 plus APR 0.17 divided by n, that's 12, raised to the negative ny. That'd be negative 12 times y, which is 1. So here, using our calculator, we got, I'm going to clear this out. Left parentheses 5,700 times 0.17 divided by 12, close parentheses, divided by, and then left parentheses 1 minus, and then left parentheses again, 1 plus 0.17 divided by 12, close parentheses, and then hit your hat key for your exponent, then left parentheses, negative 12 times 1, close the parentheses, get out of the exponential part using the right arrow key, and then close the parentheses, finally, and then hit enter. So here we got, let's say to the nearest cent, as they say, $519.87. So on this $5,700 credit card balance, if you want to pay it off in 1 year, this is the amount that you need to pay, $519.87. So that's part A. In part B, what's the total paid since January 1st? In this case here, we have $519.87. You're going to pay that off, well, they're 12 monthly, so they're 12 months in a year for 1 year. So just simply multiply $519.87 times 12 times 1. You'll get $6,238.44. So the total pay since January 1st, assuming that you have not made any charges on that card, that'd be $6,238.44. That's the total paid. Now, part C, they want the percentage of the total paid, that is interest. Okay, here's how we find out what the interest is. We take the total that was paid over that year minus the principal, which is that credit card balance. So the total paid was $6,238.44 minus the principal of $5,700. And that would give us $538.44. That's the amount of interest that was paid over that 1 year period. Okay. So now the percent that is going towards interest that's the amount of the interest divided by the total that was paid over that 1 year on that credit card multiplied by 100%. So we got $538.44. That's the interest divided by the total paid of $6,238.44 multiplied by 100%. And in this case, we will round to one decimal place for that percent. 538.44 divided by 6238.44 times 100. To one decimal place, it'll be 8.6. So 8.6% of the total that was paid on that credit card will go towards interest. Okay, here's another example. Suppose that on January 1, you have a balance of $5,900 on a credit card whose APR is 21%, which you want to pay off in 1 year. Assume that you make no additional charges to the card after January 1st. So here you're going to calculate your monthly payments, and then when the card is paid off, how much will you have paid since January 1? What percentage of your total payment from Part B is interest? Okay, so Part A is finding out our monthly payments here. So let's start off with identifying what we have. Okay, a $5,900 balance, that's your principal. The APR is 21%. 21% as a decimal will be 0.21. Take 21, divide that by 100, drop the percent sign, you'll get 0.21. And then in 1 year, that's your Y, we're making monthly payments, so N is going to be equal to 12. So in Part A, we're going to find that monthly payment using this formula. PMT is equal to P times the quantity APR divided by N. Oh, that's going to be divided by 1 minus, and in parentheses, 1 plus the APR divided by N. That's raised to the negative N times Y. Okay, now let's substitute. Let's substitute into this formula here. That P is your $5,900 times the APR of 0.21 divided by N, that's 12. Now all that's going to be divided by 1 minus, and then left parentheses, 1 plus APR of 0.21 divided by N, that's 12 again. That's raised to the negative N, which is 12, and Y is 1. So it'll be negative 12 times 1. Okay, so now let's do 59. Well, let's first do left parentheses, then 5,900 times 0.21 divided by 12, close parentheses. That quantity will be divided by, and then left parentheses, 1 minus, left parentheses, 1 plus 0.21 divided by 12, close parentheses, then the half key for your exponent, left parentheses, negative 12 times 1, close parentheses, and then use your right arrow key to get out of it. And then close the parentheses, and then hit enter. I must have did something wrong here. Oh, I see. This should be a times sign. 5,900 times 0.21 divided by 12. There we go. Sometimes you have to try to check your check what you put in to see if you put in the right thing, because that can make a whole big difference in getting the correct answer and getting the wrong answer. In this case, it's $549.37. So if you want to pay the card off in 1 year with a $5,900 credit card balance, you must pay $549.37 per month. So that's part A. Part B. We want the total paid since January 1. Okay? So this person is paying $549.37 per month, and there are 12 months in a year. That's 12 months for only 1 year. So if we multiply 549 times 12 times 1, you'll get $6,592.44. That would be the total amount that was paid since January 1st, assuming that we don't make any charges on that card during that year. Okay, now part C is the percentage of the total paid that is going towards interest. All right, let's find out how much interest we're going to pay in that 1 year period. That's just doing the total amount that's paid minus the principal. The total amount that we paid is $6,592.44 minus the principal, which is $5,900. Now, if you subtract $5,900 from $6,592.44, that means the interest is $692.44. That's the amount of the interest that is going towards that particular, that you're paying. So the percent on interest is, of course, the interest paid. I'll just say interest divided by the total amount that's paid times 100%. Because we want to change that to a percent. So the interest is $692.44 divided by the total paid of $6,592.44 times 100%. To the nearest, to one decimal place, it'll be 10.5%. So 10.5% of the total that's paid will go towards interest. Okay. Okay, now let's talk about mortgages. A home mortgage is an installment loan designed specifically to finance a home. Now, there is a down payment, which is going to be the amount of money you must pay up front in order to be given a mortgage or other loan. We also have something called closing costs. Those are fees that you must pay in order to be given the loan, and these can include direct fees, which is appraisal and credit check. There's also fees charged as points, where in this case, each point is going to be 1% of the loan amount. and sometimes called the origination fee or discount points. A fixed rate mortgage is going to be one in which the interest rate is guaranteed not to change over the life of the loan. An adjustable rate mortgage is going to be one where the interest rate changes based on the prevailing rates. Okay? That's the difference between a fixed rate mortgage and an adjustable rate mortgage. Okay? All right, now let's look at an example that is dealing with mortgages here. And there are two options here. All right, you want to compare monthly payments and total loan cost for the following pairs of loan options. Assume that both loans are fixed rate and have the same closing cost. Here you need a $160,000 loan. In option 1, it is going to be a 30-year loan at an APR of 9.5%. Option 2 has a 15-year loan at an APR of 9%. Here you want to find the monthly payment for each option, and then the total amount paid for each option, and then compare the two to find out which appears to be the better option. Okay, so in this case here, let's identify that P is $160,000. Okay, now, in option 1, the APR, you are told, is 9.5%. That means, as a decimal, it would be 0.095. And it's going to be a 30-year loan, so Y is equal to 30, and also monthly means N is equal to 12. Now for option 2, your APR is only 9%, or as a decimal, 0.09. This time it's a 15-year loan, so Y is equal to 15. And again, it is monthly, so your N is going to be equal to 12. Okay. So now let's look at the monthly payment for option 1. I'll do this down here. Of course, the formula for that would be P times your APR divided by N, all divided by the quantity 1 minus, in parentheses, 1 plus APR divided by N. That's raised to the negative N times Y power. So in this case here, your P was at $160,000. Times your APR is 0.095 for option 1, divided by N, that's 12. Oh, that's going to be divided by 1 minus, left parentheses, 1 plus APR of 0.095 divided by 12, raised to the negative N, or negative, N is 12, and your Y for option 1 was 30. Okay. If I type all this in, left parentheses, 160,000 times, left parentheses, well, actually I don't need that, 0.095 divided by 12. Close parentheses. And then divided by, and then left parentheses, 1 minus, left parentheses, 1 plus 0.095 divided by 12, close parentheses, press the hat key, and then negative 12 times 30. That can be done with or without the parentheses. Use your right arrow key to get out of the exponential part and close the parentheses. To two decimal places, this will be $1,345.37. Now that represents the monthly payment for option 1. Option 2 we're going to use the same formula here, but we're just going to substitute a few different values here. That P will still be $160,000 times 0.09 for your APR. This time is 0.09 divided by N, that's going to be 12. All that's divided by 1 minus, left parentheses, 1 plus your APR, that's going to be still 0.09. Divided by 12. That's going to be raised to the negative N times N times Y. N is a negative 12. Your Y this time would be 15. Okay, type that in the calculator, left parentheses 160,000 times 0.09 divided by 12, close parentheses, divided by, and then left parentheses, 1 minus left parentheses, 1 plus 0.09 divided by 12, close parentheses, and then press the hat key, negative 12 times 15. Right arrow to get out of it, close the parentheses, hit enter. Now the two decimal places, this will be $1,622.83. Okay. So for option 1, the monthly payment will be $1,345.37. For option 2, it will be $1,622.83. Now, for the total payment for each option here. So in this case, for option 1, I'm just going to say total here. Here you got $1,345.37 per month. And this is going to be for 12 months in a year for 30 years, because it is a 30-year loan for option 1. So $1,345.37 times 12 times 30. This will be $484,333.22. That will be the total payment for option 1. Now for option 2. In option 2, the monthly payment will be $1,622.83 per month for 12 months in a year for 15 years. And option 2 is a 15-year loan. So 1622.83 times 12 times 15. That'd be $292,109.40. Okay. Now, based on these two options here, which would appear to be the better option? Now, if you look at it, you may think that option 1 would be better because of the lower monthly payments here. But in the long run, option 2 would be better than option 1, because in this case here, in option 1, you're going to be paying more. It's going to cost you more over the life of the loan than it would for option 2. So in this case here, option 2 is the better option. And that's only if a borrower can afford those high monthly payments over the entire term of the loan. But in the end, you won't be paying much interest. Okay. All right. Here's another example. You need a loan of $150,000 to buy a home. Calculate your monthly payments and total closing costs for each choice below. Briefly discuss how you would decide between the two choices. Okay, in this case here, choice 1 has a 15-year fixed rate at 7% with closing costs of $1,600 and no points. Choice 2 is a 15-year fixed rate of 6.5% with closing costs of $1,600, but this time 4 points. Okay. So we know our principal is $150,000. Now let's look at choice number 1. In this case here, choice number 1 has an APR of 7% or 0.07. You're going to be making monthly payments here, so N is equal to 12. Because we want to find out what are the monthly payments. Y is going to be 15 because it is a 15-year fixed rate, 15-year mortgage. Okay. Now, let's find out what that monthly payment is going to be, PMT. So I'll go ahead and rewrite that formula again. Okay, now let's substitute into that formula here. Your P is $150,000 times the APR of 0.07 divided by N, that's going to be 12, all divided by 1 minus, and then left parentheses 1 plus 0.07 divided by 12, raised to the negative N, negative 12 times Y, which is 15. So left parentheses 150,000 times 0.07 divided by 12, close parentheses, divided by, and then left parentheses 1 minus left parentheses 1 plus 0.07 divided by 12, close parentheses, press the hat key, and then negative 12 times 15, right arrow, close parentheses, hit enter. To two decimal places, I have $1,328.24. So here, for choice one, the monthly payment there will be $1,348.24. Okay, now for choice two. This time, the annual percentage rate is 6.5%. As a decimal, that will be 0.065. The P is still $150,000, so we're still finding monthly payments, so your N is still going to be 12, and Y will still be 15. Because choice 2 is a 15-year fixed rate. So, to find the payment, or PMT, okay, I'm still going to use that same formula, but I'm going to go ahead and just do my substitution here. In this case, that P was 150,000 times your APR. This time is going to be 0.065 divided by N. That's going to be 12. That's going to be divided by then 1 minus, in parentheses, 1 plus 0.065 divided by 12. That's going to be raised to the negative. N is 12 times Y is 15. So now, left parentheses 150,000 times 0.065 divided by 12, close parentheses. Then that's divided by, and then left parentheses, 1 minus, left parentheses, 1 plus 0.065 divided by 12, close parentheses, press the hat key, then negative 12 times 15, right arrow to get out of it, close parentheses, hit enter. So the two decimal places, the monthly payment here for choice 2 will be $1,306.66. Okay. So the monthly choice for monthly payment for choice 1 will be $1,348.24 and $1,306.66 for the monthly payment of choice 2. What would be the total closing cost for choice 1? Now let's think about this for a moment. We have direct fees. Those are your fixed amounts. And then you got points here. Now keep in mind, as I mentioned earlier, each point is 1% of the loan amount. Each point is 1% of the loan amount. So if we look at choice number 1, there are no points. Okay? That's given to you, no problem here. That told you there are no points here. If there are no points, you also have a closing cost of $1,600. Okay? So now, your total closing cost that's just going to be that $1,600, okay? Because you have no points. That means 0% of whatever that loan amount is. So it's just going to be plain $1,600 for the closing cost. Now, for choice 2, it's a little bit different. Here we want to find out what its total closing cost is going to be. Notice here in choice 2, it was 4 points. Okay. Now, I did say that each point represents 1% of the loan amount. So if we have 4 points, that means this is going to be 4% of whatever that amount of the loan is. So your total closing cost is whatever the closing cost that they have given to you, plus, in this case, 4% of the loan. Now, you were given $1,600 for its closing cost. We're going to add to it 4%, which is 0.04, times the amount of the loan, and that's $150,000. Okay, everyone see that. Closing cost is $1,600. 4% of the loan, that's going to be 0.04 times $150,000. And that's going to give you $7,600. Okay? So the total closing cost for choice number 2 will be $7,600. Now, why might choice 1 be a better choice based on these answers here? Choice 1 might be a better choice because of the lower closing costs if you compare the two. Now, why might choice 2 be better? Well, in this case here, if you look at the monthly payment for choice 1, that's this amount, and choice 2, it's lower. So here, choice 2 might be better because of the lower monthly payments here. Okay? Okay, finally, let's look at adjustable rate mortgages. An adjustable rate mortgage, or short ARM, is where the interest that you pay changes whenever prevailing rates change. Because of the reduced long-term risk to lenders, ARMs generally have much lower initial rates than fixed-rate loans. Okay? So in example 9, let's say we have a choice between a 30-year fixed-rate loan of 4.5% and an adjustable rate mortgage with a first year at 2%. Neglecting compounding and changes in principal, estimate your monthly savings with the ARM during the first year on a $225,000 loan. Suppose that the ARM rate rises to 8.5% at the start of the third year. Approximately how much extra will you then be paying over what you would have paid if you had taken the fixed rate loan? Let's start with the approximate monthly savings with the ARM during the first year. Okay, to start that off, we need to find out what the amount of interest paid. Okay, you're given 4.5%, a fixed rate loan at 4.5%. That's going to be 4.5 times the amount of the loan, which is $225,000. Now, in this case here, 4.5% as a decimal will be 0.045. Multiply that by 225,000, and that will give us the interest paid. 0.045 times 225,000. That will give us $10,125. Okay. That would be the interest that we pay on that loan. Now, the interest on the adjustable rate mortgage, the first here we have an adjustable rate mortgage with a first year rate of 2%. So we need to find out what's 2% of $225,000, which 2% as a decimal will be 0.02 times $225,000. This will end up being $4,500. That would be the interest on the adjustable rate mortgage. Now let's find the difference in these two amounts here. So the difference in the interest paid, that's going to be $10,125 on the 4.5% minus the $4,500 on the interest on the adjustable rate mortgage. If we subtract $10,125 minus $4,500, we should get $5,625. That's the difference in the interest paid. Now we need the monthly savings. Okay. Now to get the approximate monthly savings, we take the difference in that interest paid, which is $5,625, divide that by, well, monthly savings. Now this is for a whole year. There are 12 months in a year. Divide that by 12. So here, 5,600 divided by 12. If I was to round that off to the nearest dollar, that decimal will be 469. So we're looking at a monthly savings of approximately $469. Okay. And now, approximately how much extra will be paid per month with an ARM during the third year? Okay. In this problem, it does say here, suppose that the ARM rate rises to 8.5% at the start of the third year. So here, after that third year, your rate has increased to 8.5%. Okay? So now we want the interest on the ARM during year 3. That's going to be 8.5% of the $225,000. 8.5% would be 0.085 times $225,000. So I got 0.085 times 225,000. This will be $19,125. Now, let's get the difference in the interest paid, which is at $19,125. We're going to subtract from it this amount, the interest paid at 4.5%, $10,125. That difference will be $9,000. Okay. At $10,125, that came from this amount here with a 4.5% fixed rate. Now, what would be my monthly increase? Because it asks how much extra per month. Let's take that $9,000, that 12 months in a year, divide that by 12. You'll get $750. So that means you're going to be paying $750 extra per month. Let's say that if the ARM rate increases to 8.5%, beginning with the third year. Okay. All right, so that's going to complete this video on loan payments, credit cards, and mortgages.